Well, it's an absolute pleasure to be here. And, as we've been organizing this for the last 5 or 6 months, Alicia and I and our wonderful team of people, there have been times where I'm like, this is a lot of work. But then I kept on thinking, I really want this time of like 3 or 4 days where we can all be together and talking about science. So what we had last night, what we get today, what we'll have tomorrow, definitely makes it all worth it. So I'm just really pleased to have these conversations and have all of you here. I just wish we had more of the people who are joining us virtually. I wish people could join us here in person, but hopefully next time as well. So this is sort of the motivation for this is thinking about methods. And so, we've talked a lot over the last couple of days about the various different physiological markers that we can look at things like stress and connect social conditions with health through physiology, specifically stress physiology. And so we've had a number of conversations about ways that you measure things and advantages and disadvantages. So what I wanted to do with this talk was actually to put something in where I spent some time talking about methods. And so there are a lot of us who are really interested in working outside of the context of a clinic or a lab. So specifically doing population-based research and doing work in populations where we could use non or minimally invasive measures to be able to get at physiology and health. And so that was the motivation for creating this talk. It was also the motivation for the 2 workshops that'll take place tomorrow. So first of all, we have one that Bertie Shirtcliffe, who's an expert on stress and health and specifically looking at cortisol, is going to run from 9 to 11 tomorrow. And then we're also running one on the point of care devices, many of the ones that I'm going to be talking about today. I do want to acknowledge that this is a co-authored project with several of my former grad students who are now off and doing wonderful things of their own and sometimes coming back and collaborating, and then also Alicia as a current grad student and collaborator on this. Okay, so really the way I've organized this talk is thinking about it as kind of addressing 2 questions. One, how do we use point of care testing to measure relevant biomarkers? And then also, what do we need to know in order to use point of care testing appropriately and effectively? So thinking about the practical as well as the ethical issues related to that. I also wanted to acknowledge, several years ago, I started flipping all my acknowledgments so they were at the beginnings of talks rather than at the end of talks, because I think it's so important for obviously acknowledging them, but also getting at the motivation or some of the reasons for having these types of studies in the first place. So this actually originally started as a NSF grant focused in on methods development, specifically building the biological anthropology toolkit for looking at various different physiology and health issues using minimally invasive measures. We've talked a little bit about the World Health Survey. I'll get back to that in a little bit, but we've had contracts with them to help develop the World Health Survey instruments, especially around biomarker and point of care use, and so I just wanted to acknowledge their funding for this. Also had a session at the physical anthropology meeting several years ago that actually presented what came out of this grant. With a number of people, including some in the room, like Zachary. And then we've got 2 special issues. So one of American Journal of Human Biology that was published in early 2021, and then another one that's the November edition of this year, so 2022, that focuses in on minimally invasive biomarkers. So the starting point that I have here is thinking about, I guess, first of all, the need, right? So the real need to link up the specific physiological pathways that go between social and environmental conditions and physiology and health, right? Trying to get, especially from things like, for example, discrimination to health. How do we do that? What are the specific physiological pathways? And one way that you can do that is looking at specific biomarkers to identify the specific pathways, not just one pathway, but often multiple pathways going from whatever environmental conditions we're talking about to the endpoints in terms of health and well-being. So there's this need, especially in populations and population research, and especially working with groups outside of the sort of standard laboratory and clinical context that we see in many high-income countries. So one of the ways to approach this that's really been pushed over the last several decades is dried blood spots, or DBS. And so really thinking about this as a way to go and work in terms of collecting these in a field-friendly, minimally invasive way. Something that's acceptable to people, something that you can use in the context of a field setting, whatever that field setting is so that you can collect these things, not have to use, for example, electricity or a centrifuge or things like that, and then be able to take those samples back to a place at some point and analyze those in a lab. So DBS was really kind of central to this. And so I was part of a paper that was published in Demography in 2007. Tom McDade led it, along with Sharon Williams and myself, was kind of a review called What a Drop Can Do, which is basically talking about all the different opportunities that come from using dried blood spots and what we can get from them. What are the advantages? And a little bit about the disadvantages, but it was very positive, optimistic, and I think that reflected what we thought at the time about how easy it was to do that kind of research. So it was seen as a fairly easy way to obtain these high-resolution biomarkers, and essentially that the sky was the limit, right? That we collect little drops of blood, we bring those back to a lab, and we can really basically get everything. And if we can't get something now, we can develop an assay for that, and it would cost maybe $10,000, $15,000, and we could validate it and use that. That was kind of the optimistic perspective in the early 2000s. It's fun to criticize your own work and I guess be around long enough to be really critical of the stuff that you do earlier in your career. Anyway, this is a picture from our first year doing dried blood spot collection in Ecuador. So this was 2008. And so thinking about dried blood spots and finger pricks to get blood for that as being something that's particularly useful when working with groups like kids or older adults or people who don't want to work with or have needles used. So here's just I'm sure everybody's familiar with dried blood spots, but I just wanted to show a picture of sort of the collection here in terms of the very small, like 50 microliters of blood being collected onto a filter paper card. We do this for most people who are born. You have a neonatal heel stick collected and tested for various different metabolic abnormalities. So over the last really 5 to 10 years, and especially trying to work out the biomarker analysis for the SAGE project, so this big WHO aging project, where we collected biomarkers, but then didn't have any money to analyze biomarkers. And me and several others were tasked with figuring out what we can do with basically nothing. It really led to us recognizing a number of problems. I mean, the flaw of that design of a study, do something with no money, but also the complexities of trying to get at some of these health indicators that we really wanted to look at, but also these aging measures, things that we could look at as understanding this physiological process of aging, and then thinking about how we do this methods development. And so it became clear that there were actually far more challenges than what we had thought in that early paper. So first and foremost, many of the potentially valuable biomarkers were unavailable. And so really, because this hasn't been commercialized, it was sort of dependent on individual researchers to do the work themselves and identify what that marker is and then validate a measure to do that, which is complicated, it requires expertise, et cetera. So if you want to do something, sometimes that meant you actually had to validate the biomarker first. So it could be a long process doing that, and I will come back to that in a little bit. Oftentimes, our estimates of how much something would cost tended to be fairly optimistic. The procedures for that assay optimization tended to be more complicated, and then also there were issues working from lab to lab, right? It was thought, wow, we can do this in pretty much any lab, we can compare across labs, and it's not going to be that hard. I think if we really thought about it more at the time, I feel like it's sort of naive that we thought we're so optimistic about this. We would have recognized these problems before we published that paper. And then there are the issues that come from the fact that you're collecting capillary blood, right, from your fingertips, and you're collecting the red cells within that drop of blood, whereas when you're looking at venipuncture, most of the time what you're doing is taking that blood sample, spinning it down, getting rid of the red blood cells, and then looking at the serum or the plasma. So we're looking at small quantities of blood in these dried blood spots, but we also have a significant portion of that blood spot is red blood cells, and it's a varying amount of red blood cells per spot. So there's all sorts of issues that can come from that. So really, I guess the perspective we came to maybe 7 or 8 years ago was that we shouldn't abandon dried blood spots, but that we really needed this new renewed investment in dried blood spots. I always call it DBS 2.0. Maybe that's an outdated way of talking about it, but thinking about that we just kind of need a reset and sort of like, how do we do this at a different level and have different expectations and sort of different approaches to this. That's awesome. The other piece here that I think is really important, especially talking about point of care, is that there's no way you're going to analyze dried blood spots in most field settings. So really what it's requiring is a separation between whatever that field is and wherever that lab is. So the expectation is that you're taking this thing, you're going back somewhere, and then maybe you're publishing it, but then it makes it harder to get that data back to the communities that you're working with. And that may be easy or hard depending on where you're working, but it's something that's a huge challenge in a lot of different communities. So we, a number of us have been working on this paper for quite a long time, and at some point it will come out. It's got a number of components to it, right? There's a large review of this, how it connects to the literature out there, but then also kind of a detailed step-by-step white paper sort of guidelines for how you actually can do this. And we've been publishing this and publishing validations with this methodology, so nothing really should be surprising, but it's kind of a detailed methods guide to how to do this. And so hopefully that will be out within the next 6 to 9 months. What I wanted to now focus in on is point of care devices and thinking about this as something that's a supplement to what we can do with dried blood spots. So yes, we've got this work to do with dried blood spots, but we also want to think about the other tools and techniques that we can use in field settings and when is something used versus something else used. And so this crisis with dried blood spots hasn't been something that's just coming from my lab or the labs of my students, but it's also coming from others. So for example, like the Health and Retirement Survey, which is a big study that takes place longitudinally in the US, has recognized that issue with dried blood spots and has gone to venous blood samples after having these ideas of like, yeah, we're definitely going to do dried blood spots too. Wow, there's a lot of issues here. We really need to concentrate on actually doing the getting the phlebotomist in, collecting the blood samples, and then analyzing those for what we need. I think more and more studies that had initially gone to or wanted to go to dried blood spots, if it's been easy, many of them have switched back to venous blood collection, especially because of the interest in things like cytokines, which are circulating often in very low quantities. And so when you're collecting something on a small amount of blood on a blood spot card, and you're collecting something that's circulating in low quantities in the bloodstream, you're going to have problems. And so many of the things that people want to measure, like IL-6 or TNF-alpha, create problems for measuring and quantifying these, especially in populations that have very low levels of those. So certain populations, it may be easy if they've got these very high levels of inflammatory markers, but other populations, that can be a real challenge. So if we want to be able to look across the spectrum, we need to find different ways to be doing this. So partly because I'd started integrating point of care testing to be able to deliver health results back to communities, that led me to then think, okay, well, how much can we actually use from point of care testing that's built into the research? Are there ways that we can expand the markers that we get from point of care so that we can then limit the number of markers that we're using from the dried blood spots? Or how do we use those in creative combinations? So when we think about point of care testing, many are highly accurate, many are clinically validated, some are coming out of sort of the Western clinical healthcare market so that they have to be analyzed. Some are focused in on multiple analytes simultaneously. Other advantages are, allows immediate access to health data. This can be extremely valuable when we think about places like Ecuador or Siberia, where people may not have access to results. And so that limitation, if you collect something, take it back to a lab, and then try to deliver results, in practice, often that had been like a year later in best case scenario, that those results came back. Point of care theoretically creates this better situation where you've got instantaneous results. And then we can think about this as then being supplemented with the non-blood biomarkers and other data. I think last night in our discussion, I was talking about Melissa Liebert's work with cortisol. Melissa's a former student here who's now a professor at Northern Arizona University, collected amazing cortisol data, so 9 samples per person in Schwarr kids, so 3 times per day for 3 consecutive days. So we can look at those types of markers as well. And then also supplementing it with high resolution, for example, growth data. This is a former student, Sam Erlacher, measuring lower leg length to look at growth in a Schwarr girl. And so just so that we're clear, I wanted to make sure to put in a definition here about point of care testing. So point of care is fairly obvious what we're doing, but measurement at or near the patient or the participant, and then typically with results relatively quickly. So oftentimes you're getting results in seconds, sometimes maybe 5 minutes or so, but relatively quick. You'll see patient and participant used, or I'll use it in different, I'll use different words there. When I'm talking about participant, I'm talking about a research study. Patient, I'm talking about somebody who's coming out of a clinical environment. And so point of care testing could be used in either of those, and sometimes those are overlapped as well. Usually these point of care devices are collecting samples minimally invasively, so often they're designed for finger stick and capillary blood collection, relatively easy to use. I love this picture. This is my daughter just before she turned 7, and she was helping out at a health fair that I was running, and what she wanted as a reward for helping out, I had her like handing out Band-Aids and stuff like that, and I was expecting that she was going to say, oh, I want like ice cream, or I want to go see a movie, and she's like, no, I want to do a finger stick on you. And I was like, wow, so proud. Oh, wait. I'm kind of scared now. Anyway, so this is her collecting hemoglobin on me for use of the, using the HemaQ device. So easy a 6-year-old can do it. And then you can see this is our little field setup in Ecuador from several years ago. And you can see the point of care devices here. We've got 2 of these CardioCheck units and then 1 of the HemaQ units, and then all the different supplies that go with that. And so you can think about, you pack this in a backpack and pretty much take it anywhere and set up a little clinic, even in somebody's house or community center or somewhere like that. So as you saw in the title, it's after Theranos, right? And probably a lot of people are familiar with the story. It's sort of one of the many ongoing sagas that doesn't seem to end in this country. But it's one where she's been convicted of fraud and is waiting sentencing, which is supposed to happen, I think, next week. But she has filed for a new trial, and there's a bizarre story around this. But basically, the rise and fall of Theranos, I think, is really important for thinking about point of care testing, because it's actually hugely influenced what's out there and what's not out there. So really, the short version here is Elizabeth Holmes, who was the Stanford dropout from, I think, chemistry or biochemistry, who after her freshman year decided to drop out and open this and found this company in Silicon Valley that basically had this universal, and I have that in quotes, sort of infinite capacity point of care device. And so this really developed, especially in 2011, 2012, 2013, and really this was getting a lot of publicity and massive amounts of investments. So probably on the order of $800 to $900 million of investments. She was one of the wealthiest people in the world. And oddly enough, or kind of it's surprising, I guess, is that me and my lab manager at the time, Gita Ike, who's since left and is now a nurse at the local hospital, she and I had started working on this project with an engineer up at Hewlett-Packard and a couple of his students, graduate students in engineering at OSU. And we started working on this device and actually had a prototype that could actually do biomarker development or biomarker analysis. And we actually had it to the point where we were looking for venture capital to expand this. So this was in 2012. And everybody kept on saying, well, we're not going to give you money because Theranos is doing everything. And so at first it was kind of like, okay, we can fight this. And then they were just getting these huge investments. And so me and Gita just started digging in of like, what can we find out about this company and how they're doing things? I was very skeptical. Both of us were very skeptical. And we both came to the conclusion back in 2013 that this was all fraud. Like there was absolutely no way they could be doing what they said they were doing. And even though they were very cryptic and tried not to reveal things, they still were revealing enough that we knew there was something really wrong. And then they had a scientific advisory board with no scientists on it, which is never a good sign. Politicians and Henry Kissinger and various random folks who are closely connected to power and money. So it really shut down the point of care testing market around the US, but also around the world as well, as it was clear to many people that this was the next big thing and why invest in somebody else doing this. And so we ended up starting a company that then crashed and burned in 2016, and we ended up returning all our money. We had state money from state of Oregon to develop this, and it was in small quantities, right? Hundreds of thousands of dollars, not in the millions that we would need to really take this thing through clinical trials and take it to market. So we just decided to exit, and thankfully, I kept my academic job and I'm happy in my academic job, but it was very interesting to then see this get exposed. And so there's a fantastic book that reads like a sort of detective novel written by a Wall Street Journal reporter, John Carreyrou, called Bad Blood. Highly recommend it because it's great. I mean, it's a sad story, right, in terms of this commentary on what people get away with and what are the problems of, sort of investment in biotech. But it's also interesting because he's really smart in terms of even though he didn't have this background or doesn't have a background in biochemistry, really nailed the problems with this and was able to see not only the limitations, but also the possibilities. So interestingly enough, as Gita and I put together the first draft of this paper that then got published last year and is the basis for this talk, we came independently to the same conclusions as him about ways to approach point of care testing if you wanted to get something that's universal, that has this incredible capacity for measuring different things. I should say, while Theranos is obviously the most spectacular crash and burn, there's other ones, right? So this is a group that came out of UC San Francisco that has run into problems related to microbiome. It's not the lack of ability to do this in a technical sense, but it's the fraud associated with this product that became their downfall. That, oddly enough, the people who ended up creating this were somehow connected to Theranos, and they've now fled to Germany. And because the researcher, one of them is a German citizen, I didn't realize Germany won't extradite her to the United States or her husband because they're connected, which I thought was really interesting. So that's now just waiting for them to ever come back to the United States. And then last week, a couple weeks ago, we had another blood testing scheme that was promising this device that could do everything. And now that's clear that, in fact, that's fraud as well. So not only the fraud associated with the business practices, but fraud associated with marketing something that doesn't really exist. And in many cases, it couldn't exist. So there's the part of me that really wants to develop this sort of holy grail, whatever, tricorder kind of thing that one could look at any health measure. But that's the future, perhaps. But we have many things that we can look at now. And even though they don't give us everything that we want, they give us a large amount of those. And I think there are ways that we can push to develop new point of care devices that can get at many things. But I'm sort of skeptical about this holy grail device, despite the fact that I probably hear once every week or two about a new one that is the next big thing. And oftentimes it's sort of a word salad of different, scientific sounding words that, graphene is the way that we're able to do that. I doubt that, right? Or even if it is, it's a very, very, very long road for proof of concept, deployment, and then also validation in a clinical sense. So I think we're 10, 15, 20 years away from anything that would look like that. And certainly Theranos pushed us back. So the current landscape is that there are quite a few of these commercially available devices, many that use blood, other ones that use urine, and then other ones that we don't usually think of point of care devices, but they actually are. So here's first of all the urine one, but point of care devices like ultrasound machines. So this is my former student, Felicia Matamenos, who's now a professor at CUNY Queens College, who's using, this is part of her dissertation research that then she's continued on, looking at bone mineral density in the context of Shuar population in Ecuador. So we can think about these as not taking blood or some biological sample, but there's something that's giving you immediate results that you can then work with a participant or a patient in whatever context you're working in. So there are many commercially available devices, and they use different platforms to get at things. And so kind of what I was alluding to when I talked about the Carey-Rue book and then what Gita and I had done as an analysis was looking at the different approaches and saying there is absolutely no analytical technique that we could ever use that is going to get at every single one of the markers that we're interested in looking at that would be relevant to health and physiology. But you could look at using these different platforms, for example, immunoassay or hematology, and get a combination of these, right? So I think what we were trying to say was the minimum number of platforms to have a pretty infinite number of possibilities would be 4. And oddly enough, the Carey-Rue analysis, I'm sure from his interviews with various people, came to exactly the same conclusion. And so this is including various different non-communicable disease measures, infectious disease-related biomarkers, and then various biological or physiological parameters. Just to give an example here of a device, this iStat measure, this is running somewhere between $15,000 and $20,000, so this is kind of on the expensive side of things, but it has a capacity to measure a variety of different analytes out there. These are often now being used more in clinical settings where you can, in minutes, get results. But they're typically not being used by anthropology researchers or people doing the kinds of things with population-based research, especially outside of high-income countries. But there are ways to use those. I should also say there's lots of regulatory issues. So oftentimes these are validated for particular areas and can only be shipped to certain areas. So oftentimes moving the cartridges and the devices around or shipping them to different places can actually be fairly complicated. The US has actually a pretty strict and complicated regulatory system compared to Europe and other parts of the world. So I think we've also limited the number of point of care devices that can get approved in the United States simply because of the system. And I think there's some advantages and some disadvantages to that. WHO also has a process where they actually look at different types of devices in this sort of assured criteria to see kind of how they work with populations in terms of things like, are they equipment free? Are they affordable? How easy is it to work with these? So the basis for this talk is this paper that's, I guess, technically still in press, but it's been out now and available sort of in the in-press form for not quite a year, but it is formally part of the special issue for American Journal of Human Biology that comes out in November, led by my former grad student, Teresa Gildner. And it's really this up-to-date review of the blood-based point of care testing as it would be applied in most human biology research. So that is emphasizing sort of the non-high income populations and emphasizing especially those populations that are in remote or rural areas. What are the things that we can take to them? So when we did this is actually just a little bit of a table from the article. We actually went through and talked about all the ones that are out, all the ones that are about to come out, and then things like the sample type and quantity, the diagnostic types, the costs of those, and then field friendly, and then analytes. There's also another table in here in the article that actually gives some examples of studies that have used these so people can see those to get an example of the types of ways of applying these. So our thought was that this would be incredibly valuable for people who wanted to start up this research. This was a huge amount of work just to get this information together. So just, I wanted to give a couple of examples here of ways that we've applied this. So first the Schwar project, which I've talked a little bit about, and then also the World Health Survey Plus, which is sort of ongoing, and we're in the planning stages right now. So when we're thinking about the Schwar research, this has been going on since about 2005, and really thinking about this work as being done with an indigenous population that's in a very rural area in Amazonia and Ecuador. And it's actually, we've worked now with about 6,000 people. We don't have point of care health data on 6,000 people, but it's definitely several thousand people at this point, because we've integrated point of care testing as a really important part of working with individuals and communities and providing health information. And so for that project, we've focused in on hemoglobin, and that's something of interest for people, especially as it's related to parasites, but then also some of the non-communicable disease markers, which are really valuable as we're thinking about a population in transition, as nutrition is changing, as activity patterns are changing, and we're seeing those changes in terms of risk for things like diabetes and heart disease. So we're measuring total cholesterol, HDL, LDL cholesterol, triglycerides, as well as glucose with the CardioCheck PA. So the HemoQ and the CardioCheck, we're talking about instruments under $1,000 and samples. And just to give you an indication here, so looking at hemoglobin, actually less than $1 per sample. And then for a full lipid panel, it runs about $15 per sample. And then for WHO's World Health Survey Plus, which I keep on changing. Every time I talk about it, I change the start date. It's like 2020 launch, 2021 launch, 2022 launch. I think I should probably just put 2023 launch. It's, as you might imagine, really complicated to get these things to launch. There's so many different players here. I know, and the people who are involved in it in this room are sighing, because we've got 5 undergrads and then 2 grad students working on this project along with me here at U of O. And I probably shouldn't on camera or being recorded say it's a nightmare, but it's challenging. It's very, very, very challenging. And so the hope is that this starts soon and rolls out in Ghana and Cambodia, and then a variety of other countries. The World Health Survey that ran in 2002 to 2004 had about 70 countries involved. So the hope is to actually have this go to many countries around the world, ones that don't have national health surveys that are nationally representative. But so for that, measuring hemoglobin, hemoglobin A1C, which you've heard about a few times today, and then also glucose and lipid panels as well. That's connected then to various different other sort of survey, functional measures, blood pressure. And one of the things that we've been doing here, which we'll talk more about tomorrow in the workshop, is developing these protocols for the standardization of these collections. So, I mean, these point of care devices are wonderful to use, and they're really robust in many ways, but there are ways to not use them properly and end up with bad data. So what we've done is create a training plan and then the sort of do's and don'ts of how you work with those. So thinking about some of the advantages and disadvantages of point of care devices, and this is sort of the last part of this talk. So thinking about the advantages in terms of disease surveillance and research purposes, so immediate access to data, right? Again, contrast with the dried blood spots. You don't have to worry about losing your samples during transport. So one of the things that we've run into problems with the Ecuador study is having to transport our lab samples, so dried blood spots, as well as urine and saliva from Ecuador back to the United States. And that's incredibly challenging in the context of this environment, because even though we have permission to do that from the Schwar Federation and the local groups, it's ultimately the country of Ecuador that decides on that permitting for getting that stuff out of the country into the US, and the relationship between Schwar and the Ecuadorian government is bad. So getting those permissions can be really challenging, right? So there's lots of issues related to the logistics of getting these things. So if you can do it with point of care testing, you've managed to circumvent those. Also labs, you don't have to, you can set up a lab out of a backpack and with some solar panels rather than having some, huge investment to maintain. Participants have immediate access, that you can often engage people in their own health and creating opportunities for both individuals and communities to be engaged with this. This is from some of the early Siberia work. This was a physician colleague of mine who I collaborated with back in 2003, and one of the things that we did there was we collected these, used point of care devices for lipid panels, and then also glucose, and then we provided that information back to individual participants in the study. Each participant got to meet with a physician to talk about their measures, and then also another person to kind of interpret sort of nutritional and lifestyle choices. And so that was built into the study, which really does very different things for recruitment of participants in studies, but also really, I think, can be very helpful for people, especially people living in areas without any access to those resources normally. This is the picture on the right is from some of Felicia Matamenos's work. This is actually from a Wenner-Gren blog because it was supported by one of the engaged grants from Wenner-Gren, basically looking at the community level of this. So not just providing results back to individuals and thinking about them in a clinical setting, but providing results back to communities to talk about health risks, right? So one of the things that we've dealt with and written about a little bit, including on that blog, was talking about the risks that are to come, right? So the sad ones that, people are really worried about diabetes in these rural Shuar communities, even though we're not really seeing diabetes, but they're seeing in people who have gone from these rural communities up to, to Quito and other big cities, you're starting to see diabetes rates go up. And so essentially it is educating people about what is likely to be coming given the changes in lifestyle that's happening in the population. So it just creates a possibility for community engagement that you don't have. It's not as easy if you're taking all those samples out of a country and then trying to bring back results later. But then some of the challenges here, right? So not available for all desired biomarkers. There's no overarching plan for the development of point of care testing. It's really dependent on the market, and the market is very connected to high income countries and especially the insurance market, right? So I think figuring out a way to navigate that where we could find different funding sources to develop point of care testing that actually looked at different markers that we wanted to, not just those health markers associated with chronic diseases that are connected to insurance, right, and you could bill for, but what are the physiological markers that we could look at as then getting a window into health change before it's really leading to these sort of severe disease processes. So right now we're dependent on these large companies, but there are ways around this if we're thinking creatively about, for example, what NIH or NSF might fund in the future and different approaches to that. There are also issues with working with these devices in particular places like, lowland Ecuador, right? You're working in a highly humid environment. It's very different than a climate-controlled lab in a place like the United States. So thinking about what's required in order to make those devices function well. And sometimes that's like, keeping something in a cooler with desiccant to keep the humidity down, and then only taking it out and using it, for when you're actually working with somebody, but not leaving it out exposed to the elements. So there's different kind of protocols for approaching this. Again, these can be on the cheap end of things, so $800 for a device, $1 per sample, or they can be the other end of things where it may be $20,000 for the device and then $50 for each of these cartridges. So, the price points matter in terms of thinking about how to do this, and you also want to be thinking about how you do these trainings, right? It's sometimes going to take a bit for people to become proficient in this, and so we want to make sure that you build in those costs to be able to do these things well. Really excited to announce this one. As I put together these slides the other day, I wrote under review, and then 3 days ago I got to turn it into in press, so this got accepted. So this is a paper that's kind of the follow-up to the After Theranos paper that's led by Felicia Matamenos, and it's really thinking about how we actually apply these in sort of real-world settings with population-based samples. And so thinking about the practical issues that I've been talking a little bit about, but also the ethical issues, right? Thinking about how you apply these in the context of communities which you tell some somebody they have diabetes, or you tell them that they have something, and then there's the potential that you leave, and what do they do, right? So it's thinking through how you actually think about this in a responsible, ethical way, and what are the things that we need to do as researchers to be thinking about this. So there's lots of ethical challenges to think through here, but many of these create opportunities. So we can think about like building these in and actually, finding ways to engage individuals and communities. One of the other things to be thinking about in terms of these challenges is really thinking about what are the disease burdens in different places. And so, one of the limitations with these point of care devices is that many are designed for looking at those conditions that we're dealing with in high income countries, right? These chronic diseases like cardiovascular disease and diabetes. And oftentimes that's not exactly what you want to look at in some of these low and middle income countries, but it's increasingly becoming an issue, right? So thinking about then what's the burden in local populations and how we look at what's important now, but then also think towards the future. The other thing to keep in mind is that much of our research is funded by research grants that are usually 2 or 3 or 5 years. And so it's really hard to have, especially international work, that has some continuity of funding for 10 or 15 or 20 years. And so the funding mechanisms that we typically use make it challenging to have this long-term investment in health. So even like studies with Siberia, where we were active going back and forth pretty much every year for 12 years, that was really hard to keep funded. And oftentimes we ended up in different places, not necessarily because we were desiring to go to a different place, but because of political reasons, the sort of larger geopolitical issues that got us sent to different parts of Siberia. So there's lots of ways to think about this and do things differently, but I think we have to move beyond these sort of typical like windows of 5-year research grants or 2-year or 1-year research grant. How do we think about continuity? If we're going to start a study, how do we ensure that this is something that can go on for 10 years or 15 years? What is our exit plan from that? And I don't think most people think about those kinds of things as they're designing studies. So how do we build capacity? How do we build sustainable infrastructure? How do we invest in locals? And this is obviously easy to say and hard to do. And I think we've had some successes and failures in the various different studies that I've been involved in. But I think having the conversation about this is really important. So I think really what I want to say is not that point of care testing is the solution to everything, but it provides an incredible tool for changing some of the dynamics and changing some of the approaches that we use in our studies. So not only to enhance scientific findings, but also start to deal with and help mitigate some of the persistent global health inequities. And so in many ways, this follows what Madeline was talking about earlier today in terms of thinking about this with these large-scale studies. And so these two papers are really motivated by the work that we're doing with the World Health Organization, where it's absolutely mind-blowing to me that as we are developing the tools for this World Health Survey, when we started, putting together the little, data forms that you can return, or data cards that you can return to individuals who are participating in the study, they wanted to write on them, like if the values are high, go see your GP, go see your general practitioner. Right? And we're thinking about only low and middle income countries. And when we said, really that's probably not going to apply to most people here, how do we think about a more sophisticated way of dealing with the fact that if somebody has values outside of the range that they should be, right, the healthy range, how do we help them get tracked into care? This is the first time that WHO has been dealing with that based on measured data, right? So most of the time they're talking about self-report data. This is one of the first times that you're actually seeing data that's going to be collected from point of care devices that are clinically valid measures And it's leading to these questions coming up about how you do that in a responsible way. So what are the things we have to do in terms of delivering results? And then if we're delivering results, how do we do that in an effective way where people can understand that and then we can get them to where they need to be? And so really one of the things that Madeline was developing in her paper and that we've been talking about, a group of us have been talking about more and more, is thinking about how you basically balance good science, right, and doing science in a way that's objective with working with these underserved communities. And I think the longer and longer that I do this, the more I get frustrated with the, hey, let's just do the science, get these results, and maybe we'll help people a little bit, but we'll go maybe somewhere else, right? I've been guilty of this too. But I get frustrated with that approach. Easier, quicker now, and say, we actually really need to be thinking about what we're doing and how do we help people, right? And so I think what's interesting about this, as I type this out and change the color so it would be bold and whatever, you can see it, it's simultaneously, I think, a really radical thing to say, right? That we really should be more activists or as much activists and agents of change for these communities. And it's also not radical at all, right? Because I think more and more as we apply for grant funding, for example, National Science Foundation, we have to have well-developed broader impacts in our grant proposals. And many of those are about changing the current situation, either with the researchers doing the research or the population you're working with. There's got to be some change that's in those broader impacts. So we've got to this position now where I don't think we're really doing it very well and intentional and talking about it, but we are trying to be, on one hand, good scientists who are objective observers, and then simultaneously good humans in terms of trying to change things for the better in communities. So I think I would just call for us to have these conversations about how one maintains rigor in science and objectivity in science and work with populations like we've been talking about here, Shuar or rural Russia, where they don't have access to things and we provide valuable services by going there. How do we do this in a better way? So anyway, the conversations that we've had around Madeline's work and then around the WHO project, I think is really useful for thinking about how we apply this in anthropological studies, but also these larger population-based studies like done by WHO. So just a couple of take-home messages here. So first of all, point-of-care testing can be used effectively to measure biomarkers and population-level research, but studies have to be carefully planned because of limitations in what's out there, and then also as a result of the practical and ethical considerations. And that we can really see enormous opportunities for point-of-care testing for fostering this collaborative research and increasing access to health information, but that we really need to actively be working to use these and other tools to mitigate these persistent health inequities that we see in many of the communities that we all work in. So with that, I'll stop and welcome your questions.